Hello and welcome back. In this video, we're going to take a look at how the graph of sine is obtained, and we're going to be using the unit circle to do so, okay? So we need to know that unit circle. We need to know how to evaluate the unit circle, okay? And what I got here is 5 different radian measures here, and I'm trying to evaluate sine of 0, what is that? Sine of 2 pi, what is that? And what I want you guys to do is pause the video here and go ahead and fill out those 5 values, all right? And I have the unit circle right up here to show for it. All right, so hopefully you went ahead and got these 5 values. Now remember, when we are evaluating sine, we're basically just thinking about what is the y coordinate at that angle. And the y coordinate at 0 is 0. So sine of 0 is 0. Sine of pi over 2, well, pi over 2 is right here. Y is 1. Sine of pi, 0. Sine of 3 pi over 2 is negative 1. And sine of 2 pi, well, we just do a full rotation back up here at 0. Okay, now I picked these angles on purpose. If you notice, it's all the angles that kind of section off the quadrants. Okay, it's these 4 angles. I guess you could say 5 angles because we hit 2 pi again. But it's those 4 angles that block or that kind of section off the 4 quadrants. Okay, and what you should notice is that for each of those points, it's a nice number. It's like 0 or 1 or negative 1. Now we could do the exact same with all these nasty radicals, okay, but we're going to go ahead and avoid those. All right, and now what we're going to do is we're going to actually graph sine using these values. So every radian measure we put in is our our independent variable. So 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians, not 3, 2, and 2 pi radians, okay? And then the y coordinate, the dependent variable, is what we got. So we got 0 at sine of 0, we got 1 as sine of pi over 2, we got 0, negative 1, and 0. So I'm actually just going to go ahead and plot all these points, and now I have what my scale should be. I have what our scale should be. And let's go ahead and make that graph. So at 0, we're at 0. So we're at the origin. Okay. Now at pi over 2, we're up here at 1. At pi, we're back down at 0. At 3 pi over 2, we're back down at negative 1. And at 2 pi, we are at 0. Okay. So these are the points on our graph. And I'm going to go ahead and connect these using a nice curve. Not that nice, I guess. Using a nice curve. There we go. Not too bad. And that is part of the graph of sine. And I say part because we only grabbed a few angles. We could keep going on and on and on forever. And that's what I want to show you right now. So as you can see here, I have our unit circle, and notice we're just going around the unit circle, and this is how we're obtaining the graph of sine. All right, and notice we stopped at 2 pi, but this pattern would just continue forever and ever and ever, going further and further in each direction. You don't see it going to the left, but it does go to the left as well. It actually goes left and right forever. Its domain is actually all real numbers. It continues from left to right in either direction forever. So the domain is all real numbers, and we're just getting a nice smooth curve by going along our unit circle. And notice this is 2 full rotations because we're ending up at 4 pi and not 2 pi. Okay, so that's how we obtain the graph of sine. Now that we've seen that, I want to talk about a couple of things. So you may have seen the previous video where we talked about what's called periodic functions. Okay, and this is an example of a periodic function. Okay, now it's periodic because it continues that same pattern over and over and over again, and because it's periodic, it has a few common, or I shouldn't say common, a few key characteristics. It has what we call an amplitude. Now remember, amplitude is just half the distance from max to min. So if we think about what the amplitude of this particular graph is, well, the max is at 1, max of 1, and it has a min of negative 1. And regardless if I continue this forever and ever, you would see it have the exact same max and min. Well, that total distance is 2, which means half of that distance is 1. So it has an amplitude of 1. Another way we can think about amplitude is how far from the midline we traveled to hit the max and min? Well, the midline in this case is just this x-axis right here, which is y equals 0, is that horizontal line that cuts this graph perfectly in half, okay? And you can kind of think about it as the average of the max and min. If I did 1 plus -1, I get 0. Cut that in half, I still get 0. So y equals 0. And that also bodes well because our maximum, we traveled up 1 from that midline, and the minimum, we traveled down 1 from that midline. So that's another way we can talk about amplitude, okay? So it has an amplitude of 1 and a midline of y equals 0. And the last thing that we want to talk about with periodic functions is the period. Remember, the period is just the horizontal length of one full cycle, okay? And if we look at this, we started at the midline, we went up to the maximum, down to the minimum, and back up to the midline. And that's when the pattern repeated itself. That's when the cycle repeated itself. And what is that full distance? 2 pi. It took a full horizontal length of 2 pi to complete one full cycle. Okay, so the period of this graph is 2 pi. And all these numbers should kind of make sense. The amplitude is 1 because we never go above or below -1 and 1. We don't go above 1, we don't go below -1. So that should make kind of sense why the amplitude is 1. The period is 2 pi because we unwrap the unit circle to get this graph, and notice one full rotation around the unit circle is 2 pi. So that's why the period is 2 pi. Okay, so that is your basic graph of sine. Okay, in the next video and videos to come, we are going to be translating the graph of sine. We're going to be changing its amplitude, its midline, its period. We're going to be changing all those values. I'm going to kind of walk you through it, so make sure you check out those videos, all right?